Okay, let's discuss the method of reduction of order to solve a differential equation. First of all, recall that if you have the fundamental set for a second order differential equation, if y1 and y2 is the fundamental set for a homogeneous second order differential equation, then we have the following observation. y2 divided by y1 is not a constant. y2 of x over y1 of x is a function like u of x. So what's the meaning of that? It means that we can write y2 as the multiplication of y1 and u. So what's the meaning of that? It means that if we have y1, then we can easily find y2. Let us take a look at the following example. This method is called the reduction of order. Example. Let y1 be equals to e to the x be the solution of the second order differential equation, the second derivative of y minus y equal to 0. Question says, find the second solution. Okay. Based on the fact that if we have a fundamental set, like y1 and y2, for a second order homogeneous differential equation, when you form their quotient, it's not a constant. We know that y2 over y1 is equal to a function like u of x. Okay, so y2 of x becomes y1 times u of x, but y1 is given to us as e to the x, ux. So to find y2, they have to substitute that into the differential equation. To find y2, substitutes y2, the second derivative, and y2 in the d. So let us take the first derivative because we need the second derivative. The first derivative of y2 using the product rule becomes e to the x, ux plus e to the x, u prime of x. Now, the second derivative of y2 becomes, again, you can apply the product rule, e to the x, ux plus e to the x, u prime of x plus. Here you have e to the x, u prime of x, and plus e to the x, the second derivative of u. So let us substitute the whole thing into the differential equation. In the differential equation. So what do we get? We get, can we simplify this more? Here we have e to the x u prime, e to the x, so we get 2 e to the x u prime. We have e to the x ux plus 2 e to the x u prime of x plus e to the x u second derivative of x minus y. But what is y? Y is e to the x ux equal to 0. Very well. So as you can see, e to the x ux minus e to the x ux, they are opposite of each other. What's left? You have e to the x times 2 u prime of x plus u second derivative equal to 0. Since e to the x is never 0, you have to set the quantity inside parentheses equal to 0. E to the x is never 0. So what do we have? We have 2u prime of x plus the second derivative of x equal to 0. But how do I solve this differential equation? To solve this differential equation, let us do a little trick. Let us use a substitution and reduce the order to the first derivative differential equation. Let us reduce the order by a substitution. Okay, very good. What substitution? Instead of u prime, use a function like w. So w is equal to u prime. What do we get? We have the following. We have 2w of x plus w prime equal to 0. So w prime plus 2w is 0. As you can see, it's a linear differential equation, which is linear differential equation. So since we have a linear differential equation, we need to find the integrating factor. The integrating factor is e to the integral 2 dx, which is e to 2x. Now multiply all terms, left side, right side, by e to 2x. You get e to 2x, w prime plus e to 2x to w equal to 0. So as you can see on the left-hand side, you have the dx of w e to 2x, and on the right-hand side, it is just 0. So w e to 2x becomes, well, the integral of 0 is just c. Okay, so far so good. But what is w? W is u prime. So u prime is equal to c e to negative 2x. So u of x becomes the integral of c e to negative 2x. So your ux is equal to negative c divided by 2 e to negative 2x plus a constant like k. So what do we have here? We know that y2 is equal to e to the x ux. So let us just substitute that here. Your y2 becomes e to the x times, here you have negative c over 2 e to minus x minus 2x plus k. So you get y2 of x equals to negative c over 2 e to minus x plus k e to x. But note that here you have your y1 as e to the x. So this is unnecessary. Set k equal to 0, and then here you can just get rid of this coefficient by setting c equals to negative 2. So y2 becomes e to minus x. Very well, the fundamental set that we have is e to the x and e to minus x. The method of reduction of order.